थोड़ा साइड में या हाँ आप आगे पीछे आप करेंगे, ये भेज दूँगा। ठीक है। Very good morning to all of you. I am very thankful to Professor Pawan Patnaik for giving me this golden, valuable opportunity to share my thoughts with this auspicious and learned gathering in this AICTE sponsored VAANI FDP program, which is going to be held from 24th to 6th September. That means today is 25th September 24. So, as you know, that topic of today's session, that is IoT in smart manufacturing. IoT, before coming on IoT, I would like to give you some brief outline of industrial revolution, various development which has taken place and has revolutionized the world. In computer, if you are mostly, I think, computer science faculties, students, research scholars, you might be knowing that first generation, second, third, fourth generation we used to teach in computer science. But now we are going slightly wider, and in that wider manner I can put you in a summarized way that industrial revolution 1.0, 2.0, 3.0 and 4.0. And industrial 1.0 started sometime around the year 1800, and water and steam engines came in this era. Steam engine, I think that you people might have not seen or experienced this steam engine, but I am fortunate that I have travelled in steam engine trains. So that way, water and steam engine, that means first time engines came. You can think, you try to imagine what would have been the world if there were no engines. Some people think that word engineer has come from engine, although that is not true. I don't want to go in that how this engineer word has come. That is associated with one Latin word anyway. Second industrial revolution started sometime in 1900. You can see the gap, about almost 100 years after first revolution, and that was the era when electricity came in. You cannot imagine the world without electricity. That means industrial revolution, that means not small developments, research and developments, things which have revolutionized the entire world, society, humanity. That is called revolution. So industrial revolution 2.0, and one example, that is of slaughterhouse, came in Cincinnati, USA. That was first of its kind, which was on a mass scale, and that had taken a shape of that industry. After that, industrial revolution 3.0 came in around 1950, and in that period of time electronics came in, diodes, transistors and ICs, etc. And we are greatly influenced nowadays with this electronics development, you know. And then industrial revolution 4.0, which is at present, that means IoT, HPC and all these things, automation, etc. All these things started after 2000. You can think that at around a interval of 50 years, this industrial revolution 4.0 started coming in. Next slide. So IoT, Internet of Things, you might be knowing something, but I am adding something from my side. Suppose we are in computer science, you know what happens in computer science or even in our daily life. You can say that these eyes, nose, our tongue also, ears, these are just like sensors. Sensors means we are receiving the signal from our environment. And then what is happening after we have received? Somebody has said something and we have received. We have, that means heard. After that it is processed in brain. And what after that? Response, reply. That means action. These are the three basic things, and this thing is applied in your operating system also. One, थोड़ा सा मजाक के लिए मैं बोलूँ, wherever I go for interview etc., I ask what is kernel. People say, candidates say, it is the heart of operating system. Then I say, what do you mean by heart? Then he will say, it is the brain. What is the technicality behind that is expected. Similarly, I ask, what is CPU? It is the heart of a computer system. Then somebody will tell, it is the brain. Okay, lekin what is that? What is control unit? Somebody will say, it is the heart of or brain of this CPU. Unless you tell that control unit is supposed to give control signal, then I would have asked next question, from where this control signal is coming, what are various types of signals, what are control buses, etc. Technology is important. So here also IoT is also working on same principle. This is not other thing. Whatever we are realizing, we are facing and we are doing in our day-to-day life. Similarly here also, as you know that IoT, that means there are a large number, very large number of sensors. Even in your mobile phone also 5-6 sensors remain present. 5-6 sensors means for one, maybe for GPS also. In blood pressure machine, BP machine, nowadays it has become a home appliance. There is sensor which, that means measures, that means it starts measuring the tick which is coming. Similarly, blood sugar measuring machine, which is also a home device nowadays. There is also sensor. Everywhere there is sensor. If suppose sugar or BP is higher or lower, whatever, then what you do? You go to the doctor. Then doctor gives some medicine. Then you start taking that medicine. Here also there are various sensors, very large number of sensors which are gathering data. In IoT, afterwards also we will see there are very large number of sensors which are distributed, and those sensors are sensing and giving their input signals. Therefore, this concept of big data is applied. These are all interrelated. I will tell about HPC also. These are all interrelated. Alone IoT, alone big data, alone HPC, that is of no use unless until it is applied for some bigger task. So, because volume, how you can say that how big data is applied? Because large number of data is coming in through various sensors, and that too continuously it is coming. So it is big, it is volume, large in volume. Velocity also is there, that means data is continuously coming, and variety, that means various types of data is coming. HPC, you can say how HPC is involved. So everywhere, even in our daily life also, fast decision making is very important thing. Fast decision and correct decision both. Everywhere. So suppose large number of data has come in, inputted, but what after that? You have to process that data, analyze that data. How processing of data will take place? How a decision will be taken place? In such a fast manner, after processing this large amount of data, so it is possible through high performance computing, HPC. Incidentally, HPC is my area also, and I have uploaded more than 50 lectures on high performance computing. In my YouTube lecture, Dr. Sanjay Kumar, India, persons, that is for non-profit, not commercial purpose, but only for the sake of students only. So there, how HPC, now you can say how HPC. So I am not going into the detail of HPC here, but in very short, because you may also have come across the word GPU, graphical processing unit, GPU. Again, in this session I am not going into the detail of GPU, but in very short I would like to tell that GPU belongs to SIMD category. You will say, what is SIMD? So I think that you might be knowing SISD, SIMD, MISD, MIMD, that is Flynn's classification scheme, and that is an essential part of this computer architecture everywhere. So with this GPU processing, it is possible, there are various processing elements, data can be distributed and processed parallelly. Therefore, this is called high performance computing. Data is processed parallelly on various processing units, and that comes under the architecture of SIMD, means single instruction stream, multiple data stream. What is SISD, SIMD, MISD, MIMD, I am not going to cover here in this session. Anyway, so now after giving this background of IoT, I am coming on this. IoT is the interlinking of digital devices, people, machine, appliances and other objects with one another through wireless network. Of course, wired network is not possible to deploy, and therefore wireless network, it allows machines and people to be connected to each other and communicate as well. It is considered the future of internet. Connecting technologies may be Wi-Fi, Bluetooth, cellular networks, IP version 4, 6 and UDP protocols are used in IoT. Since, as the name says, in IoT means full form is Internet of Things. Things means various objects, devices and internet, and now it comes in the area of computer network. Computer network, internet and computer network. You know what is internet? It is made up of the word internetwork, that means network of networks is called internetwork. And wide area network, again there are around 15 or 20 lectures of mine in computer network only, you can see that also. IP version 4 and 6 you might have taught in your classes. This is 32-bit, IP version 6 is of 128 bits, IP version 4 is 32-bit, means 2 raised to 32 addresses are possible. IP version 6 is of 2 raised to 128 bits, means 2 raised to 128 addresses are possible. And Internet of Things, you can imagine, after coming of this Internet of Things IoT, how many internet enabled devices might have been there in entire world and on earth. So is it possible to address, because each and every internet device has its unique IP address. So how to address such a large number of internet enabled devices? That is why IP version 6 came in. And as I told, with IP version 6, how many IP addresses are possible? 2 raised to 128. I would like to give one example. ये 2 raised to 128 क्या होता है? Each and every particle of sand on this earth is possible to be addressed with 2 raised to 128. Such a large number is this. So it is thought at present that for coming years it is sufficient. So that is why IP version 6 is sufficient to address all these internet enabled devices. So things means objects, maybe any type of thing, not only this computer, laptop, mobile, anything. It may cover a large number of things in which this sensor and this internet enabled device is available. Maybe stethoscope also, maybe anything, clock also. Since we are computer science people, therefore everything we see, we try to see from this computer science point of view. Although Internet of Thinking, as Dr. Santosh Mishra is there, he is from mechanical engineering. This is all interrelated, interdisciplinary, I would like to say. This now all these things are, all the branches of engineering are getting merged. Electrical, electronics, computer science, IT, mechanical, everything. Anyway, since we are computer science, we try to see from this angle. So protocol stack, you know, OSI reference model, physical data link layer, network layer, transport session, application layer. These are OSI reference model. OSI reference model, now you might be teaching, but if I come on concept, then what is concept of behind that OSI reference model? It has given, OSI reference model is given by ISO, which is a standardizing body. Now you will ask, what is standardization? What is the need of standardization? Everywhere there is a need of standardization. Even nut bolt, this 5 ampere plug or 15 ampere plug, that means electrical supply, 50 hertz supply, that is possible with other dimension also. A scooter mechanic says, वो 2 नंबर का पाना ले आओ. What is this 2 नंबर का पाना? It is everywhere same in dimension. This plug, diameter of that hole is same everywhere. That is why you can buy from anywhere and start making use of this. OSI reference model is also like that. This is not actual implementation. This is a standard given by ISO. But now question arises, after this standard, what is the practical implementation? TCP/IP is practical implementation. Similarly, in IoT, TCP/IP is basically meant for wide area network and this internet. For IoT purpose, this is the protocol suite. That means network access, internet, transport, application. Again, I am not going into much detail of these things, but this is the IoT protocol suite. What will be the various protocols, etc. For example, in TCP/IP, we are familiar, HTTP, FTP, SMTP, SNMP, these all the various protocols. Similarly, here also then again will come various protocols. Invention of IoT. In 1989, David Nicholas and his colleagues at MIT invented the first IoT device. However, the term Internet of Things was firstly used by Kevin Ashton in the year 1999, and he was employed at that time in Procter and Gamble. Security in IoT, I will tell afterwards also. This security is very important thing in IoT. You will ask why security is such an important thing in IoT? Because Internet of Things, that means, as the name suggests, internet, it is making use of internet, and internet means public network, and through that internet means public network, that particular action is to be performed. Now that signal is becoming publicly visible. In your college also you have one very good idea lab established by Professor Pawan Patnaik, which is unique. In idea lab also you might be seeing various things, 3D printing machine and various other things, with the help of which you are able to manufacture various things. But whatever you are doing, that is private to you, or it is between you and the whatever vendor, or if you are going to supply somewhere, that is not the publicly accessible thing. Other example, suppose some operation is to be done, suppose this tumor is to be removed by doctors, and with the help of this Internet of Things and the smart manufacturing, I will see, and virtual reality, it is possible to perform remote operations also for doctors. And for that purpose, suppose doctor is here, patient is somewhere in some other place. Of course, communication is to be established and fast internet is required. That signal is going through that public network, internet. But you know that patient data is private. Patient data is not supposed to be given in public domain. Therefore, there is a need of security. Then how to secure? And it is not also possible that you start deploying a private network for each and everything. Establishment of private network is very costly affair and very tedious affair. Very few countries in the world have their own full-fledged private network. Otherwise, what is the solution? It is virtual private network. That means we are using internet, but with the help of that virtual private network, we establish a tunnel, and through that tunnel, data moves in form of, that means in encrypted form. Therefore, others cannot see within that tunnel, and even if they can see, they will not be able to understand. And for that, IP security protocol is used. You might have heard the name of IP version 4, IP version 6, but IPsec protocol is the advanced form of that only, and that IPsec protocol is used for VPN tunnel, and that is used in IoT. And IPsec protocol is also given in your standard books, Tenenbaum Trojan of Computer Network. Although generally this is not the part of syllabus of BTech, etc., but that is very important thing. So, as I told, what are the major components of IoT? So, sensor are major components of IoT. And why sensors? Sensors are used to collect data from environment. There may be various types of sensors, as I told earlier also, that even in mobile also there are some sensors. In our human body, eyes, nose, etc. are sensors. So, here also temperature sensor may be there, which is also called thermostat, thermocouple, pressure sensor, humidity, moisture sensor, light intensity detector, moisture sensor, motion sensor, proximity, etc. Earlier I had given you the example. Here, since motion sensor has come, suppose motion sensor means to detect motion, and nowadays CCTV cameras etc. are installed everywhere. If some unwanted motion is detected by sensor, earlier I was fortunate to get one UGC sponsored project that was for automatic elephant detection, which is a huge problem in this Sarguja district etc. Elephants come in the area of, that means in villages etc. So automatic elephant detection, this is a very big challenge still nowadays. Let me tell you, for government, how to deal with this problem of elephants, because of forest cutting, elephants are coming in this area. So motion sensor, suppose alright, motion sensor has sensed the movement, then after that, as I told earlier, just sensing the movement is of no use unless until you take some preventive action also, and for that processing of data will be required, and after that some action will be needed. And therefore, after data successfully uploads to the cloud, computing software and big data analytics process it for end user, what I told, that processing of data. Then actuator actuates the unit. For example, if temperature is above 400 degrees centigrade, then governor opening of boiler will be reduced to reduce the temperature. Similarly, if a suspicious activity is noticed by the motion sensor, some mail or SMS or notification will be triggered, then some agency will perform that activity. Some motion has been sensed, then what will happen? In our UGC project, which I have told for automatic elephant detection, if some elephant is coming or crossing in from, that means in front of that camera, then one SMS and email will be triggered to some destination. That means some triggering or something, some action is to be taken. And let me tell you, this is not a new concept, IoT etc. I have tried to correlate it with our daily life, human life also. Now slightly changing the topic, when I was a student in Government Engineering College NIT, which is now NIT Raipur, my head of the department, he was using to take class of control system. Control system is taught in all branches of engineering. He had used one sentence, and since I have the habit of writing everything, so I had written that line, and then I am quoting that line here. That head of department, with due respect to him, Dr. D.N. Khandelwal, he is still, that means in good health, living in Raipur only. So he had told in that control system subject. Now I am slightly shifting. Control system was taught in the year 1987-88, and we are here in IoT. Name is new, but things were at that time also. What he told, he was teaching a topic of feedback control system. He told that suppose some feedback control system is there. One is open system, one is closed system. Closed system which has feedback system. So output signal is converted. Suppose we have to maintain the temperature in a furnace at 400 degrees centigrade. Exactly at 400 degrees centigrade. That is what we do in our ACs also. And suppose temperature goes high or temperature goes low, then some sensor will sense it, will convert it into electrical signal with the help of transducer, and will feed back. Then again I am giving you one example. For example, corresponding, very easy example from my side, corresponding to 400 degrees centigrade 8 volt. Suppose it is becoming 420 volt, it is becoming 9 volt. It is 410, it is 7 volt. That signal is fed back and it is compared with one standard signal. Difference is 1 volt or 2 volt in plus or minus. Accordingly some governor opening will be, जैसा कि नल हम लोग खोलते हैं या बंद करते हैं, will be opened or closed in appropriate direction, and accordingly supply of steam, water, whatever will be reduced or increased, and then temperature will be maintained. So the same thing is applying here also. That is why I am saying it is the name which is new, things were already there. Even study in academic institutions, study was also there, even at that time also. So these are the various types of sensors. Sensors may be of n number of types. I have given the names of few sensors in our human body, but temperature sensor, pressure sensor, various things may be there, and color sensor, humidity sensor, GPS sensor is also used in our mobile phones, as I told. So as I told earlier, that is same thing written here. High performance computing is important for the Internet of Things, because through HPC large number of real time data can be gathered through sensors and can be processed. GPUs are specialized computer chips designed to process large amount data in parallel. As I told earlier also, that जैसे बोलते हैं ना कि टीचर एंड स्टूडेंट both are incomplete without each other, both are complementary. Similarly here also, these are all interrelated things, IoT, big data, HPC. As I told, if you are gathering the data through sensors, then you are allowed to analyze that data, process that data, and then after that you have to perform some action also. So HPC is useful for processing of that data with very fast speed with the help of GPU, which I have given. Let me tell you, GPU is not only thing. I am taking the name of GPU for your convenience. If you go in MIMD category, that is a full-fledged parallel computer, but GPU is same which we are using in your laptop, etc. So this is taken from NVIDIA. NVIDIA, you might have heard the name. NVIDIA is the major big company for which gives you GPUs, and anyway, I do not want to promote any company, or so this is taken. This is the diagram of a supercomputer taken from this site only. But supercomputer word I used to teach HPC, high performance computing, and in high performance computing, books of bricks and Kaiwang and bricks, two books are of standard, are standard books all over the world. One thing is that very few number of books are available, you know, in parallel computing. And Kaiwang and bricks are the two major books which are, that means all over the world, these are the two important books. In the book of bricks, in very first page of the book, there is one sentence which is written, given by the scientist Sidney Fernbach. That sentence is maybe words slightly different. Supercomputers of 10-20 years ago are nowadays ordinary computers. Supercomputers of now will become ordinary computer after 10-20 years. That I mean to say that supercomputer is a non-technical type of word. Just like you say, this is heart, this is brain. What is control unit? This is brain. Somebody will say this is heart of a computer. So this is non-technical type of word. But various good or bad, various non-technical words have also been adopted in the industry. Doesn't matter. Actual name should be parallel computer. So I am not going into detail. If you want to go in detail, you can go through my YouTube lectures for this parallel computers. So these are the major components of this. We have already seen software, hardware and protocol stack, and corresponding to that was again I am telling that was a model. Model means reference model. From according to those layers of SI reference model, there are various protocols for actual implementation. Similarly, from that model which I had shown of IoT reference model, protocols will have to be adopted as per the requirement. And again, this we have seen. These are the control units everywhere. Microcontroller control units will be needed. Control unit, just because I had taken this name of control unit earlier also. In computer fundamental, from school time, college time, we are studying. There are three major parts of a CPU: control unit, arithmetic logical unit and memory unit. When the question comes of memory unit, everybody again gets confused. I ask the question, memory. Memory is itself a very confusing term. What type of memory? RAM, hard disk, pen drive, CD, what? ROM. Again there is a confusion. RAM and ROM. As I told earlier also, few words are adopted in industry which are technically not correct even. In the book of B. Ram of Computer Fundamental, which is a very good book, this is written, ROM and RAM. If I ask you what is the difference between RAM and ROM, you will tell what answer you will give. I am giving that answer. RAM means, sir, random access memory. Read only memory means ROM. Okay. But then I will ask, ROM, how accessing of memory takes place in ROM? Then I will answer you, that is also random accessing. Only thing is that read only memory cannot write. In RAM, which we are saying RAM, read and write both are possible, and that way name should be read write memory, जिसको हम लोग RAM बोल रहे हैं. RAM should be appropriately called as read write memory. Then this ROM name will be justified. That is read only memory, this is read write memory. Meaning is clear what I am trying to say. So various names are adopted. Similarly, this in CPU, I was telling about this CPU, control unit, arithmetic logic unit. Control unit, work of control unit is to give control signal, and control signal is just like our brain signal. That is why people say that this is brain. And if we go in detail, what is control signal? So there are three types of buses: address bus, data bus, control bus. Combinedly these are called system buses. And control bus carries control signal, address bus carries address, data bus carries data. And how this is generated? So I have uploaded my lecture of microprocessor, which is again, which I have taken from a very senior renowned professor of BIT Mesra, Kantarao, Professor Kantarao. I was fortunate to hear his lecture. So I have uploaded my lecture of microprocessor. You can go through that if you want, regarding these control process signals, etc. So anyway, so these are control units. Analog to digital, digital to analog convert is everywhere needed. If I go into that much of detail, so then we'll come on modulation. What is modulation? Multiplexing. Analog to digital, digital to analog, analog to analog, analog to digital, digital to analog, digital to digital. 4 types of modulations are present. So I am not going into that detail also here. Then what are the modulation techniques? Everything is applied in one small word, Internet of Things, IoT. People write capital O, that should be small o. ये छोटे से वर्ड में only 3 characters are there, but this is covering entire computer science engineering, in my opinion. What is left here? Computer network, computer architecture, parallel computing, operating system, electrical, electronics, mechanical. This IoT word is embedding everything within it. So various softwares, we are not going into the details of softwares, but ultimately technology behind that, concept behind that, I have tried to tell you. So edge computing, etc., hardware, and coming on this smart manufacturing, because this FDP is primarily on IoT and smart manufacturing. Just a minute. So smart manufacturing is a manufacturing process that uses advanced technology to improve efficiency, reduce cost and adapt to changing demands. The National Science Foundation of USA firstly used the term smart manufacturing in the year 2006. आजकल तो हर जगह स्मार्ट वर्ड आ गया है, स्मार्टफोन। और कल की आपको एक घटना मैं बताऊं, चलिए थोड़ा सा हट के अपनी क्लास से। LMS आप लोग नाम सुने होंगे, लर्निंग मैनेजमेंट सिस्टम, and we are giving workshop on, that means in my department only, learning management system. And in learning management system I have uploaded my notes, video lectures. I used to perform class test, assignment, etc. So in learning management system I was required to enroll each and every student in that particular schedule, and for that I have to particularly select each and every student. Then I said in my class, after finishing my class, I need the help of 1 or 2 students to come here and to make some entry in my LMS system. Then I saw that nobody is coming. Then I said, आप में से जो 1-2 स्मार्ट लोग हैं ना, वो आ जाएं। तो सब लोग आने लगे। तो स्मार्ट वर्ड इज यूज्ड एवरीवेयर, स्मार्ट पीपल, स्मार्ट पर्सन, स्मार्ट वॉच। सिमिलरली हियर आल्सो स्मार्ट मैन्युफैक्चरिंग, एज आई टोल्ड, दीज आर, ये पूरा शब्दों का खेल है। स्मार्ट वर्ड इज नॉट न्यू, मैन्युफैक्चरिंग वाज आल्सो ऑलरेडी देयर, बट द टर्म स्मार्ट was firstly used in the year 2006. And as I told, smart manufacturing, which is making use of internet, IoT devices and computer related activities, electrical, electronic signals, etc., are being used up. So IoT, smart manufacturing, SPC are all the outcome of Industrial Revolution 4.0. These are all the things are primarily the outcome of Industrial Revolution 4.0. And IoT safety, what is the help of IoT in smart manufacturing as the topic of today's session. IoT in smart manufacturing. I have told already, not only in smart manufacturing, this is useful in medical practices also. Everywhere IoT is useful. Manufacturing is not an exception. If you go on manufacturing, I had given you the example of that furnace to maintain, which was required to maintain the temperature at a level of 400 degrees centigrade. Similarly, wherever you require very fast real-time processing, for example, I am giving you one different example. Chandrayaan was successfully launched by Government of India. Missiles Agni 5 was also tested 1 week ago only. SLV-3 satellite launching vehicle, everywhere real-time data is getting processed. Satellite launching vehicle SLV-3, why the name is 3? There are 3 stages. First stage will carry up to a particular height, then certain portion will be detached and second portion will be attached, and attached means will be activated, and it will take up to certain height. Again that will be detached and again a new element will start activating. Real-time data processing, you can imagine if a single type of error is there, what will be the consequence? Failure of complete mission. Why? Suppose this has taken to this height. This is idea and example from my side. I have not read from anywhere. And from there this had to be detached and this had to take over. Suppose this is detached and this is not taken over. What will happen? It will collapse. That means accurate decision making, fast, accurate with precision, precise decision making is very much needed in factories, smart manufacturing, everywhere. Even in our daily life also. अगर कोई स्टूडेंट है वो पास हुआ, स्टूडेंट हैज़ कम आउट and that means decision at any point of time, we all know this thing. I don't want to go in much detail of that side. If you can think what is the consequence of taking a wrong decision. Similarly here also, correct, right and timely decision is very much needed, and that is needed in manufacturing also, and that is why if we are making use of these devices, IoT etc., it will be called smart manufacturing. One more example, because 15 days back I had gone to AIIMS for one dental problem. Just I am giving example from my side. Suppose a dentist is there, some filling is to be done and some drilling is to be done in your infected tooth. Now drilling, he is doing drilling. Drilling was required to be done for 1 mm and he makes the drilling of 2 mm. You will not come to know what wrong has happened to you. Work will be done. Because I am facing this problem, I realize this problem because wherever we go to dentist, they tell root canal is needed. A small problem, big problem, whatever. But it is possible, rather I have experienced this thing, that even if a small filling is required, root canal is advised. That means one for very small thing, very big type of solution is given. That is not the example of this right, accurate, perfect decision. Precision should be there. So that is all possible with this smart manufacturing, and IoT is playing a very vital role. As I told earlier also, IoT is making use of internet service, and that is why it is cheaper also, because it is not possible for everyone to deploy a private network. It is making use of internet, that means a public network, and that is why it is cheaper. How that I have told, for that security enhancement protocols like IPsec etc. will be needed, virtual private network I told you, tunneling I told you, etc. So high degree of optimization is possible. This is optimization. My that professor only I had told at that time. What is the meaning of optimization? Neither minimum nor maximum. Optimization means accurate, neither it is less nor it is more. So high degree of optimization is also possible with this IoT, and therefore it is contributing much in smart manufacturing also. This is a general diagram for smart manufacturing, private and public mobile networks. As I know that internet, I give example. Suppose in internet word is also small. Suppose I am sending one mail to just a person who is sitting just by the side of me, but that Gmail is routing from where? Up to Gmail server, which is situated in USA. So that distance is not mattering here. Similarly, here also Internet of Things, this small word may be geographically distributed to various places. Signals from various remote places might be coming to a central place. So everything you have to look in broader way, and that way cloud services are needed, public, and 5G, high speed internet, because everywhere this speed of internet matters. Now you may ask speed, rather I have also not used the correct word of speed. In my lecture you can see bandwidth part 1, part 2, part 3 I have uploaded in YouTube. What is bandwidth, what is Nyquist theorem and Shannon's theorem. What is the concept of this bandwidth? What is speed? Speed is a layman type of word, just like supercomputer I told you earlier. So anyway, security cameras etc., these are all this is all one process which is trying to show this use of IoT in smart manufacturing. Internet is also shown, etc. And as I told earlier also, what are the major benefits of IoT? Increased efficiency. So approximately 20 to 30% of gain in manufacturing system is possible. For example, Pawan Patnaik ji is not there. 3D printing machine is used in Idea Lab. You might have used because in your college it is there only. What happens to these drones? In drone, let me tell you that weight of drone matters a lot, because if weight of drone itself is more than payload, that means material which can be loaded in that drone system, that will be less, because it is limited to a very few, maybe 50 gram. The drone cameras which are used in your marriages and receptions etc., those drone cameras can carry, I think, around 50-60 gram only, 50-51 grams only, excluding the weight of that drone itself. With the help of this 3D printing machine, it is possible to reduce the weight of drone, because with a single material, with a single piece, entire structure is possible to be made without the making use of nut and bolts. So that way weight of these nut and bolts and screws etc. are reduced or eliminated, and therefore payload capacity is increased. And as I told, in drone system, weight has a very important role. With that is one example which I have given, how this smart manufacturing 3D printing machine can contribute. It can reduce the weight of drone, and therefore payload capacity of drone can be increased. Similarly, in various other places also, this was one example. Similarly, reduced downtime time around 15 to 20%. That means, suppose some fault has taken place in some factory, breakdown has taken place. You know that bringing back in a working condition is a very big challenge. What will happen if internet is down in your college? कुछ ही घंटे में हाहाकार मच जाता है कि इंटरनेट डाउन है. अगर लाइट पता चला हाफ सिटी में नहीं है, कितना बड़ा एक क्राइसिस हो जाता है. तो व्हाट इज द अप टाइम? सो with the help of this IoT in smart manufacturing, we can bring down this downtime. That means we can reduce this downtime from 15 to 20%. Improved quality also increases. Total quality management was a different area. Total quality management, how to enhance, how to improve the quality. So quality can be, that means accurately or precisely, it can be controlled. Some mixing is to be done. Then in how much proportion it is to be mixed. Then by error, some more portion is mixed. Because error also we used to teach in your research methodology also, in electrical engineering, electronics engineering, error calculation, percentage error, measuring error. For example, suppose you are measuring your height, your weight, then are you sure that it is giving correct, that means correct result? Suppose you have purchased a good smartwatch. One professor in my place had purchased very costly and very good smartwatch, and he was telling that this gives you the data of this and that. मैंने मजाक में कहा कि लगता है कि टाइम छोड़ के सब कुछ बताती है. तो उसमें जो है, then suppose it is giving some medical data. Suppose for example it is giving data that your BP is so much, or even in your home device also that BP machine or sugar machine is giving this much is your sugar or BP. You start taking medicine, and lastly you come to know that result was not itself correct. What will happen? That means correct decision, role of correct decision is so much important. I am trying to say that thing. And timely. Similarly, cost saving, of course, cost can be minimized up to 10 to 20%. Various examples can be given in that also. Enhanced customer satisfaction. Of course, after that total outcome will be improved. Cost cutting can also be done. Or that means decision making, ultimately fast decision making is done. Correct decision is possible to be taken, and accordingly we can take corrective measures on whatever actions. So challenges are also there. One major challenge I have discussed already, that is security. That is a very big challenge, security and privacy. As I told, medical data is not supposed to be given to everybody, and similarly various other data also. That security challenge, I have told about one IPsec protocol. Maybe there are more, and this may be a research area also for research scholars. security aspects in IoT. This can be taken up as a research area. Similarly, data management and analytics, how to manage this huge data and how to accurately, that means perform the processing, etc. Because everywhere chance of betterment is always there. Nothing is perfect. There is always a scope of improvement. So these are all open research areas also, you can say. Integration with legacy system, scalability and interoperability. Scalability means one advantage of IoT that it is scalable. You can go on adding more and more number of sensors, etc. But how to enhance this interoperability? Suppose different platforms are working, then how to make it interoperable? What is the example of very good interoperable system? One is internet, Java also. Java, you know, Java you teach, it is interoperable. That means in internet also, maybe Linux, somewhere in DOS, Windows, etc. different operating systems, all are traveling on same platform. So this is called interoperability, interoperable. Workforce training and adoption, etc. That means how to adopt with new technology, that is also a thing. And that is why perhaps AICTE has started this training program, HPC also you are telling, to adopt, make the people more adaptable to the new technologies, and for that such type of training programs, etc. should be conducted in order to bring about more and more awareness among people. That is also equally important. And then how to propagate it up to the village level. We are fortunate that we are living in a capital city, well developed city. We are well equipped with all latest facilities, but it is because you are so much, that means graced, you are so much fortunate. Everybody is not so much fortunate. So we have to carry this knowledge to the grassroots level also. People who are deprived from these facilities. So ultimately IoT is playing a smart role in smart manufacturing, and not only smart manufacturing, in every walks of life. So with these words I close this session. Thank you. Thank you very much. If you want to ask some question, you may ask. I will try to answer. Okay, thank you very much. Thank you. You can contact me anytime. I am in Ravi Shankar University, as my introduction was already given. And for any technical issue, technical subject related issues, you can even call me also, mail me also, and you can go through my lectures, whatever according to my knowledge I have tried to make it publicly available for the benefit of students, teachers, scholars, etc. So thank you very much once again. Thank you.